Morning students, today we will discuss about the scattering of light. So what is scattering of light? So you know that our our earth's atmosphere contains dust particles and gas molecules. So whenever sunlight enters our atmosphere, these dust particles and air molecules they first absorb the light, and after absorption they scatter they actually re-emit the light in all the directions. So this first absorption and then re-emission of light is called scattering of light. And due to this scattering, the light spread in all the directions. Okay, you can assume that this scattering is also one kind of diffuse reflection. Okay, and this scattering is depends on the wavelength or frequency of light. It depends on the wavelength of light. Now there are many kinds of scattering. Rayleigh's scattering, Tyndall scattering, and Raman scattering. But in our syllabus, only Rayleigh scattering is there. So what is Rayleigh scattering? Rayleigh was the first scientist who gave a relationship between the wavelength of light and the intensity of scattered light. He said that the intensity of scattered light is inversely proportional to the fourth power of wavelength of light. So that means if you decrease the wavelength of light, then the light will scatter more, and if you increase the wavelength of light, then light will scatter least. So you know that red light has the highest wavelength among the visible lights, and its wavelength is 8000 angstrom. So that means red light has how much? 8000 angstrom. So that means red light will scatter most in the atmosphere, correct? And violet light, it has the lowest or shortest wavelength, and its wavelength is 4000 angstrom. That means the red that means the violet light will scatter most in our atmosphere. Now due to this reason, whenever light from the sun reaches on the earth's surface, it has the less intensity of violet light, and it is not less, it is the least intensity of violet light, and the red light has the highest intensity. Okay, so most of the red light actually reaches the earth's surface. Okay, so this scattering is actually responsible for the various spectacular phenomena in nature. Okay, the blue color of sky is color of water in the deep sea. Okay, the red color of sun during the sunrise and sunset. Okay, so we'll explain these phenomena in the next slides. Okay, so just remember one thing. Okay, the thing is the Rayleigh's theorem, what I just explained, that Heisenberg intensity of light is inversely proportional to the fourth part of the wavelength. This is only valid if the size of the particles or molecules is less than the wavelength of light. If suppose if the size of the particles or the molecules is greater than the wavelength of light, then this Rayleigh's formula or Rayleigh's criteria is not valid. At that condition, what will happen? If suppose if the size of the particle or the molecule is greater than the wavelength of light, in that case that particle will scatter all kinds of light. Okay, all colors of light, blue, indigo, violet, red, everything. That particle will scatter every kind of light. So then what will happen? Then that particle, you will see this particle is white. Okay, so this particle, so Rayleigh's criteria is not valid for this kind of particles. Rayleigh's criteria or formula is only valid for those particle which has the size less than the in the wavelength of visible light. Okay, now okay, the first question is why the sky is blue. Why it is not red, green? Okay, obviously in the during sunrise sunset it appears red. So why why the sky is normally most of the times why sky is blue, because according to Rayleigh's criteria, you know that the that our atmosphere generally absorb the shorter wavelength lights. That means it no, is scattered shorter wavelength light. That means it generally scattered violet, indigo, blue, this kind of wavelength. The the longer wavelength lights like red and um, orange, they actually they actually less scattered, okay, are scattered least, and they can penetrate our atmosphere and they can reach the earth's surface, okay. Now since these colors since these colors scattered most, they scattered means they are present in the atmosphere, okay. So suppose this is your sun, okay, suppose this is sun and this earth and this earth atmosphere, okay. So these rays are coming, so blue, violet, indigo, they are scattering means they are present in the atmosphere, okay. But red is directly going to the earth's surface. Obviously do not assume that the red light is not bending. Every light which is coming, red, yellow, bending, they are bending. This is called refraction of light. Every light is going through the refraction. Red is also going through the reflection. So every light is bending but not scattering. That means they are not going here and there. Red light is direct after refraction, it is directly coming to the earth's surface. But this blue, indigo, violet, these lower wavelength lights, they are scattering in the atmosphere. That means they are present in the atmosphere. So when you see the sky, so red is not in this region, because it is directly reaching to the red or orange is not in this region atmosphere, because they are directly reaching to the earth. Only violet, indigo, blue is is present there in the atmosphere. So if you see the sky, we can, so our sky color should be violet, indigo, or blue. So the here question comes, so why sky is not violet, indigo, blue? So obviously theoretically the sky color should be violet, because the violet has the least or shortest wavelength, and that is 4000 angstrom. So we know that the violet, indigo, blue is present in this atmosphere. So why color is only blue? So to understand this, you have to observe the solar radiation spectrum. Now if you observe the solar radiation spectrum, you can see that this solar radiation actually sun actually gives us the less amount of violet or indigo light. If you see this spectrum, this sun gives us much more blue light, okay. So see the column of blue light, it is so, sun gives us so much blue light, but the violet light or indigo light is so less, okay. The sun generally gives us less amount of violet or indigo light. So due to this, when the scattering happens, so they are present in the violet, indigo, blue, they are present in the atmosphere. So violet are actually generally less in number, because sun generally gives us the less amount of violet light or indigo light. So they are present there are less amount of present in the atmosphere. Only blue is present in the large amount. So that's why when you see the sky, it appears blue. Clear? So I am repeating again, this the higher wavelength light, they scatter least light, mm, like red, yellow, or orange, okay. They directly reaches the earth. So they are not present in the atmosphere. Only blue, indigo, violet, they are scattered most and they present in the atmosphere. So but according to solar radiation spectrum, the violet, indigo, they are actually sun sends us less amount of violet and indigo light. So actually this region, this our atmosphere is actually dominated by blue light only. So that's why sorry hmm. That's why the sky appears blue. And one more reason is there also, and that reason is our eye actually consists of millions of cones to see the to see the light, okay. This you can you can differentiate you can categorize these cones into three colors: red, or green, and blue, okay. But these blue cones are actually generally sensitive to only blue color only. If you see this graph, see this graph, the graph for this blue cone. Okay, these blue cones are generally sensitive to blue light only, but their graph is rapidly decrease in indigo or blue spectrum, sorry, in violet or indigo spectrum. Okay, so these blue cones are generally blue cones are generally sensitive to blue color. So this is one more reason why we see the why we see the earth atmosphere as blue. Okay, now the next topic is why the sun appears red at sunrise and sunset. Now during the sunrise and sunset, the sunlight has to travel the largest distance. Okay. Now since at that time the sunrise have to travel the largest distance, at the time the scattering the lower wavelength light they scattered most. Okay, and they scattered even they go out of the they go out of our sight also. Okay, so only the red light, which is the longest wavelength, they scattered breeze, they scattered least, and they reaches to our eye. Okay, so since all the lights they scattered, only red reaches to eye, most of the red light reaches to eye. So that's why we see sun as, that's why we see the sun as the sun is red. Okay, these colors scattered, but they are present in the atmosphere. Okay, but the opposite case happens when the sun is sun is just above our head, that means at the noon. So at the noon, the distance between earth, the sun, at the noon the sun rays has to travel the least distance. Since at that time they all the rays has to travel a least distance, so that means all the light they scattered least, and they directly penetrate to our atmosphere, and they directly reaches our earth surface. Okay, now since all the light rays reaches our earth surface at the same time, all the mixture of all seven colors is actually white. So that's why at the noon time we see we see the sky as white. Okay, now 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 the question is why the black color of the sky in the absence of atmosphere. The very simple thing, why, so I explain why the color of sky is blue, because of scattering. If there is no atmosphere, then there will be no scattering. If there is no scattering, then you will see everything as black. So that is the same reason at the night you see, no, at that night you see the color of sky is black, because there is no light. In the absence of light, what you will see, you will see dark. Obviously, if you turn off your light in your home, you will see dark. So in the similar case, at the night you will see everything as dark. Okay, and the last thing is that the use of the red light for the danger signal. So danger signal, or for the traffic light, or for railway light, everything is used, the all the they use red light. Why? Because the red light scattered least. If you use another color, they will scatter, and you cannot see them from a far distance. You can see the red light from a very large distance, because red light scattered least. Okay, so for this reason we use the red light in the danger signals, and also for traffic signals. So thank you, we have finished this chapter. So from the next class we will start the chapter sound. So thank you for today.